Next is 4014, paper ID 4014, Comparative Performance Analysis by Miss Shradha.
Yes, good afternoon, everybody. My name is Shradha Kamshetty, and the title of my thesis is Comparative Performance Analysis of Malware Traffic Classification using Convolutional Neural Network. Basically, why there is a need of there is something why there is a need of something called as traffic classification. So as we know that everything nowadays is revolving around the internet. So uh, just as we compare as we look at the analogy of the traffic due to the vehicles, we can think about the traffic due to the different kinds of website, different kind of applications that are being used nowadays in our day-to-day life. So in that particular domain, thinking of that, we came across an idea of developing a model in which designing an image-based classifier model using the CNN to analyze some suspicious activity or some kind of malware or some kind of malicious data that is being throwing around in form of packets over the internet. So traffic classification, this is our first step for network anomaly detection. Any kind of intrusion that the network faces, and by identifying this kind of malicious form of network, what you can say, traffic, we can actually give a proper we can actually work in the domain of network security. So the main common cause, and as you can see here on the screen, but the main common cause of what you can say, the the network traffic, internet traffic nowadays is the online streaming, multimedia streaming, and the online gaming, along with all the different types of file sharing or peer-to-peer applications or FaceTime applications, or that is the FaceTime applications or Skype, uh, these kind of things. So main objective of our project included that we are detecting some kind of suspicious activity over the network, and after means once we have trained our model, afterwards we are just classifying it into two classes. One is the benign class, that is normal class, and one is the malware. So how the packets flow over the internet, first of all. So we know the OSI model, and every layer, as you can see in the on the screen, they have some form of information in the stored in the packets. So for our project, the main, what you can say, the main consideration is of transport layer and application layer. So further we'll see about this. Now initially what we did was studied the port number based. Now different the port number based features of the traffic are the very initial or first kind, very basic terms of very basic kind of features. So there are different other features such as packets or flow based features, but the port number is the very basic. So the every some so the ports are assigned by the internet assigned numbers authority. So but what happens is there are some activities that can be taken that can take place by masquerading by masking some form of ports and entering our network. So port based approach was not very feasible for large number of systems working over the particular internet, and also it will be very hard for us uh, uh, to uh, to find out the masked port numbers. So we 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 try to learn about the packet based features. So the packets that we have is there are different kinds of features allotted. So packet size, packet direction. So now what's the meaning of packet direction? Is there is a particular range that is being assigned to that. So if say around minus 1500 to plus 1500, now whatever the packets are transferred from server to client are negative, and those transferred from client to server are positive. Packet size combined with inter arrival time. Now we consider with respect to this feature, we are considering the server to client as well as the client to server detection of flows. Now, when we talk about this kind of features, there are some drawbacks of using these features, because whenever we are trying to use these features in the machine learning algorithms, so we have to make sure that we are selecting these features, that we are designing these features ourselves. So now extracting and mapping the features. Also, the proper accurate feature extraction and mapping those features with our model is necessary. Now, also, when we are talking about the malware traffic, so normal data traffic is readily available for the data set, but malware is very readily available. So we are working on different kinds of data set. We have a USDC data set, that is a toolkit which has the readily available uh, two, two, uh, two classes of the malware traffic as well as the normal traffic that we need. Now, what we are trying to do is this the initial this ImageNet and MNIST data set we can will see in the further slides now. So the two basic traffic classification methods that were studied before this were artificial intelligence based and machine learning based. Now, in this, as I have already said about the port based, that is the very basic feature set, and the deep packet inspection based. Now, in this, what used to happen is these are the specific hard coded rule based approaches. So, if deep packet inspection based has some kind of encrypted data, you cannot classify those into the malware. And in case of machine learning machine learning based methods, they use some form of selective features and they used the heuristical approach to classify those particular features. So these are the some types of classification methods. So before jumping to CNN, what we tried to understand was the learning algorithms that that have been worked on this our the internet features. So in terms in while using the naive bias classifier, we came to know that there were certain limitations because of its probabilistic way of um, uh, classification or approach, because the because it would make some initial inherent assumptions about the feature set. So this was not very feasible for our project. Now, SVM, we tried to use the SVM model as support vector machines for the classification as well. How the detection flow takes place in the project is given on the screen. So first of all, we are reading the traffic data. So whatever the data set we have collected, so that particular data set is the raw data set. So we need the data in the form which can be given as input to the convolutional our CNN model. So that raw data set is being converted into the uh, proper input that can be fed into the CNN. So this pre-processing takes place at the second level, and then after the model is being trained, we are predicting those that model. And now we all know what convolution neural networks are. So there are different forms of convolutional layers, different convolutional layers and different hidden layers. So and the fully connected layer at the end. So the basic architecture that we have used in our project of the CNN is VGG16 and ResNet 50. So the basic there were problems in there were problems of um, if the number of parameters that are there is large, so what kind of approach should be used. So we have taken the two architectures to compare the results. So as we can see, the number of layers in ResNet 50 are more, and when compared to VGG 16. Also, there is a problem known as vanishing gradient problem, in which when the mapping or convolution of the one layer to convolving the image pixels from one layer to another layer takes place, the till the layers are connected to the till the end, the gradient vanishes, or gradient becomes so small that it gives rise to certain the the problem known as vanishing gradient problem. So to get rid of this, we are using there is a mistake here. Stop connection means skip connection features uh, is being used by the ResNet. So this kind of vanishing gradient problem is taken care of in this architecture. Now the pooling layer the pooling layer that is there in that that is called as that the pooling layer that we have used in the project is our max pooling. Now we just have to remember this, that it does not have any weights. So in this layer and so this is how the convolution takes place, or the different kinds of filters, and we are applying the and taking the our output array. So how it's based on images. Now, how first of all we have seen the working of CNN, but for when we are collecting the data set, we are supposed to do the data pre-processing. So this data pre-processing consists of the number of steps. The first step is in that is traffic split. So the data set that we have is we are collecting the internet traffic, right? So we have the packet capture files, so pcap files. So these pcap files are in huge number. So split cap is a free tool to use to split the pcap files into the smaller files. So as I said that there are different layers which have the packet, which have the information in terms of packets. So we are using two types of there is a two type of representation that can be done: flow or session. In both the things, in both the representation, both the way of representation, there are packets are being given. Now these flow and session both have the 5 tuple information of what you can say, keeping the features of that particular packet. So the 5 tuple information is nothing but source and destination IP ports, source and destination port numbers, and the name of protocol. So in the flow, we are just taking into consideration that the our raw traffic is divided into number of subsets, right? So so the so the first value first first thing in our what you can say subset will be the 5 tuple information, and the second will be the size of packets and the time in which the transmission is being taking place. And the second process is the traffic clear. So there are So some what we are saying that we are representing it in a flow form and session form. In session, the bidirectional flow, how the packets are being what you can say being flow uh, con- going from server to client and then client to server. Both the directions are being included in the session layer. Now the traffic clear. Now, when we are talking about the flow, and we have to take one layer of the model, and so that we are going to study the packets of that particular layer, because every layer is having some information of the packet. So when we are considering the flow and the application layer, seventh layer, so there are some packets which have no application layer. So these files are stored not in the form of pcap, it is stored in the form of bin. So we don't want this kind of files where there is no there is a zero data in that. So in this section, yeah. So so the next step is resizing the data. So whatever the data we have converted it into the image format, and we have to make sure that size of each image is same. That is 784 bytes. Okay. Now image generation. Now once the images are generated, we can use them for the visual analysis. Like we can see here the BitTorrent file or FaceTime file, FTP file, as we can see. Now the next thing is, first when we have trained our model, so we are using the transfer learning here. So basically, the first previously we saw the ImageNet and MNIST data set. So what we are doing is we are collecting the weights that are pre-trained already. So we are taking the weights from there, and then we are using those particular weights and training our model, our CNN model on our data set. Now, when we are doing that, so this is called as transfer learning. Now we get the results as that, as we can see for BC16 and ResNet. For comparison, I have used the ROC, that is receiver operating characteristics, for comparing the two architectures. As we can see, BGG has covered the more amount of area. So BGG16 has also has the more amount of accuracy as compared to ResNet. Now, when the training data, when the data was being trained, there was we have taken only less number of epochs for that, but these are the results for model accuracy and model loss. And then the next thing that we did was we are accelerating the same thing on the high end GPU, so that number of epochs are increased, and we can test the model accuracy and model loss. So these are the results for that. And yeah, so future scope, what we aim to do is we are just right now limited to the grayscale images in this project, but we want to do this thing in the color images and on FPGA hardware or software emulator. That's it from my side.
Okay, thank you.